we have got here we have got uniform velocity and non-uniform velocity. We'll learn about that. We have known about velocity. Okay. So uniform velocity means definition: if the velocity of a moving body does not change with time, the velocity possessed by the body is called uniform velocity. I would call that body as uniform velocity. Just for example, here in the first condition, while going from this point, first point to second point, it has traveled 5 meters. Right? So calculate the velocity. How much will be the velocity while going from first to second position? What will be the velocity? Look at it. The time is 1 second. It is here is 1. That means the time interval is 1 second, and the distance, sorry, the displacement is 5 meters. That means 5 meter per second is the velocity here. Similarly, at the second position, at the second condition, while going from second position to third position, look at it. The time interval is again 1 second. Very second and the displacement is 5 meters. So what can I tell? The velocity is 5 meters per second. And if you go on finding in next condition, then in final condition, then you can see that the velocity are equal. The velocity is not changing with time. The time is changing. Here we have got 0 second. It has changed to 1 second, then to 2 second, then to 3 second, then 4 second. But the time has changed, but the velocity is remaining same. Right? So we can call this velocity as uniform velocity. So the uniformly moving body is neither accelerated nor decelerated. That means the acceleration will be 0. I will learn that while reading acceleration. Why does the acceleration become 0 in uniform velocity? I will learn that. The rate of change of displacement is constant. Okay, the displacement is not changing; it is constant, and that's why acceleration produced will be 0. So the question may be asked in exam: why the acceleration in uniform? Sorry, why the acceleration of a body having uniform velocity 0 on a certain structure? Why? Because the displacement won't change according to time on the body. Because the velocity does not change with time. You can tell this also. Or you can tell the rate of change of displacement is constant. We have got 3 reasoning here. First one, the definition. Second one, this one, the rate of change of displacement is constant. And the third reasoning, the displacement won't change with time. So this is called as uniform velocity. The displacement should be same, right? With the same time. Remember this. While in the non-uniform velocity, the velocity will change. That means it is covering a 5 meter at the first condition, right? At this condition, it is covering 5 meters. In the second condition, it may cover 6 meters. In the third condition, it may cover. In the fourth condition, it may cover about, let us say, again 6. Right? So, if this type of velocity or displacement will vary according to time, at time on displacement change with the we can call that as non-uniform velocity. Right? So, yes, the average velocity or velocity produced by a body is defined as the ratio total displacement covered by the body with the time taken. It has given as a definition. You can write my definition. So, okay. Pattern and the definition of non-uniform velocity. Next, non velocity. If velocity changes with time and called as non-uniform velocity. And let me give an example. Let me draw a straight line here. Put some point here. This is first point, second point, third point. What is some other point here? Right? Fourth point, fifth point. Right? So it is meter per second here. 0 second. Sorry, 0 second. This is at 1 second. This is at 2 second. Draw this also, right? This is at 3 second. This is at 2 second. And now we have got displacement from first to second position, second to third position, third to fourth position, then fourth to fifth. From first to second, it may be 4 meter. Then from second to third, it may be 5 meter. Then third to fourth, it may be 6 meter. Let me tell 7 meter. And here it may be 9. So we call this as the non-uniform velocity. Yeah, the rate of displacement is changing. Here, the rate of displacement is changing. Either look at it. Distance changing. At first it is 4 meter, then 5 meter, then 7 meter, then 9 meter. It is changing according with time. Right? So that's we call this as non-uniform velocity. We got
rank.
motion. Okay, come to this.